led Flux Manager project together with Daniel Christensen here. And also we have UHA, Rachel Hologras, and Deb Agua is our data team lead. So today we're going to talk about the future. Well, let's talk about today, and before we talk about future, data QQC, and let's get started. So some ground rule about today's mini workshop. So this workshop is for people, especially site teams submitting the data either regularly or maybe you just did it once, it's okay. But also for people who have interest in participating in the future of our data QQC. We'll talk about that in this webinar. But if you don't have any experience, that's okay. If you just want to learn about the QQC process, that's fine. Please stay with us. Today's mini workshop was structured by two parts. So we'll have a presentation for roughly 50 minutes. That'll be the first part. We'll talk about the QQC pipeline, the data pipeline first, and we'll go through each of the QQC module, and we'll take a break for Q&A. So this will be what we are doing right now for the QQC. And the next part of the presentation we'll be talking about what is the future of the QQC will look like, especially for this year and potentially some plan for the next year. Then we'll open the floor for discussion about how people feel about that. We have a shared Google Doc, so I think one of my co-hosts will put it in our chat. So if you feel free to adding question here or any recommendation here about the QQC process anytime. And please leave your name if you want us to follow up. This presentation part, the first part of the webinar will be recorded, and we'll post this on the website later. And please stay on mute during the presentation, but during the Q&A and discussion, please feel free to raise your hand and unmute yourself and to ask question or say anything. Okay, I would like to start the presentation with a slide. Just give you a snapshot of the Ameriflux today. This is a map of the Ameriflux site today, and including the location for all the sites here. They are color coded by different ecosystem type, and the circle indicating their the length of the data record. So today we have 567 sites registered Ameriflux, with more than 400 of them providing the data, so you can download data from them at this moment. And totally we have more than 2,800 years of data available right now. But also not just the location, the data record, but look at all this beautiful picture. It kind of highlight the beauty, but also diversity of the network here we're dealing with, right? So a lot of this thing will go into the design, but also the philosophy of our QQC process we'll talk about in the next hour, okay? So I'll pass the floor to Daniel. She will talk about the QQC pipeline.
Everyone, welcome and thanks for joining us. So I'm gonna give a brief overview of the Ameriflux FluxMet data processing pipelines here, and you're seeing on this side 3 key players. The green, you all, the site teams who are providing us with your awesome data, and then the group here, the Ameriflux Management Project, or called AMP, trying to support the network and helping y'all share your data with all the data users throughout the global Flux community. So we'll be using these color codes throughout the presentation. Next slide. So the goal of the pipeline is to produce currently these 2 data products, the base data product and the FluxNet data product. We're going to focus the presentation here on what it takes to get the base data product out the door. And as you can see, these are data that are provided by y'all. The site team, we do general QA/QC on the data. We support all the Flux processing or FP variables and all levels of aggregation. So how do we get there? Next slide. You'll see our pipeline here is a system of individual components. Again, showing here in the orange are the 3 components that take to get the base data product out the door after you submit the data. And next, I'm going to step through some of the timings involved with each of these different pieces. So for the format QA/QC, which checks that the data you submit are in the format required, immediately we kick off this QA/QC, and you'll get an email with the results of that analysis. We do, and so then for the data QA/QC which is what we'll be focusing primarily for the rest of the workshop here today. We process or do these reviews in batches every 1 to 2 months, and that's usually immediately followed by a publish events where we take all the data that have passed the data QA/QC and make those available on our website. So those are the timings for the AMP team. What that means for you is sometimes a little bit different, depends on how much iteration we have to do with you to correct any issues that we find. So for format QA/QC, it's often 1 to 2 days because we have this pretty well automated. But for the data QA/QC, it can be a bit longer here to correct some of the issues that we find. So I think one last note on this slide is that for more information, Hassan, next slide, please. You can check out some of our past webinars on the post-submission data lifecycle and the requirements for processing a site using OneFlux. And I think one of my colleagues will paste the website in the chat here for you. So let's take a little bit closer look at the format QA/QC briefly before I hand it back to Hassan. So this is a workflow of the format QA/QC. It's fully automated. And it kicks off, as I mentioned, immediately upon upload. The result is a report report email that has links to individual online reports to tell you the outcome. We do this check on a per file basis. And also we make one attempt here at step 1 to correct a number of issues that may be found. And the overall result, there's 3 types of overall results shown here at step number 2, a pass and warning, which both will queue the file for further review in the data QA/QC module, or this red fail result, which we need y'all to take some action. Okay, next slide. So this is what that email looks like at the end of the format QA/QC analysis. You'll get, again, a per file in the middle of this email section here, results with links to the individual online reports for each file that was uploaded. And then in the subject line of the email, you'll get a clear indication of what we need y'all to do. So next slide, please. So this is an example of the different online format reports that you might see. Green for everything looks good. Yellow for we might need you to take a look at a few things, especially if we made some auto corrections. And then the red one where we definitely need y'all to correct a few things before it can go further. So let's take a quick look at a report in more detail. So again, at the top, we have the overall status, and then a section where we try to clearly communicate what action we need from y'all. This middle section here, if there are any things that we need you to look at, we have them listed in this table. Again, yellows for things that need a double check to just make sure that everything looks as it's supposed to, especially if we have auto corrections. And then finally, just to note that if we do an auto correction, you'll see that QA/QC report, but if you want to see what happened in the original file, that's available too. So you can find out more information online at the URL at the top, and I'll paste that in a sec. Or it looks like Rachel's already got that in there. Thanks, Rachel. And I think that's it for this section. I'll pass back to Hassan for the rest of the workshop here.
Thank you, Daniel. So once the submit file passed the format QA/QC, we're getting to this QA/QC workflow here, showing the diagram. So first thing we did is the file, if you have any previous published base for your site, and you'll get combined here. And this step is just to facilitate, if you just want to update the latest quarter or maybe the latest year of data, you don't have to resubmit everything. It's fine. You just adding the latest year and with the corresponding I mean the same variable name, and the file will get combined here before getting to a QQC. And in the second step, we have a series of code actually run the QQC module. I will talk each one of them in the next couple slides. But this step is semi-automatically, so we run the code, and the code just went through each of the module, generate a lot of statistic figures and other stuff. And the third step would be the AMP. I think one of us will take a review of the output, and based on the review, we'll decide if this submission can be passed for publication. I mean the base data publication, or need to be returned to the site team to either verify the issue or fix some of the issue. So this is what's happening right now behind the scene. And I want to mention that there's no data filtering or any correction done here. Because what we did is just doing a check, secondary check, and before passing it to you. So let's talk about the theory, or maybe the philosophy of the QQC we done here. So I would like to say this is a secondary independent check. So we are not trying to replacing and also doing your job. A lot of QQC need to be done at the time when the data get processed. I think that's still the golden standard. What we did here, we're just taking a secondary independent check. And so the philosophy is slightly different, okay? A lot of the QQ design is based on the paper Gilberto Passarella did in 2014, and we adopt some of the idea there and also learn from the last couple of years. We're also taking the lesson learned from the Flux network, especially the previous release and what people suggest, and also maybe the common issue we found across the network. We try to incorporate that in our QQC. We're also taking the feedback from the data user. A lot of people use the data and also providing the feedback about where certain places can be improved, or maybe can be tightened, and we're taken into consideration. And also, as Daniel just mentioned earlier, another product done at the pipeline is the OneFlux FluxNet product. So we do taking into consideration about some of the processing requirement when we are asking the QQC. I want to say this QQC is more like a post hoc approach. What I mean is we have very limited ancillary information, diagnostic signal, something like that. So it's slightly different compared to the QQC done by you, especially the site team. And we have to consider the trade-off between a very specific for a certain site, but also try to be universal. So you can see down, when I talk about all these modules, there's some trade-off between try to choosing a universal approach or maybe try to be specific enough. Less, the QQC, our QQC is pretty emphasized in the visualization for two reasons. So one is we are using that pretty much for all the issue identification actually. And that's how we designed the QQC in the beginning. But also we are using the visualization for communication, especially between the site team, between us, and trying to figure out what's going on. It's quite useful in our experience. And the QQC being adopted in all the FluxNet 2015 release, and we have been done this for all the base published since 2017. So that's, I think it's a couple hundred of sites already. Yep. These are the module, the check module we have right now on the left-hand side. So you can see a list. I'll go through each one of them. And we do plan to adding new module in the future. A few of them have been already showing up for some of the site or the email you're seeing. Okay. So in the next couple slides, please bear with me. Might be a little bit more intense, but this is how we structure the slide here. So make sure we will talk about each of the check module. And as I said earlier, each of the check modules should have a figure with that. So it would be one figure and maybe some additional figure along with that. And along with the figure, we also generate some of the summary statistic, and pay a little bit attention to this because this is might be important for our future QQC process, especially for next step. And based on all this information, and this can be linked to a certain identified issue here on this point. And then we try to highlight which target variable for each of the check actually doing, okay? So first, the first check is timestamp align check. So this check is try to check if the data stream is on the right clock on timestamp. Okay, so what we did here is we're taking the show incoming radiation, or maybe PPFD, depends on which variable you have. Then we try to generate what we call a maxima diagonal composite over a 15-day window. So think about this is a 1 year of time series. Each one of them is coming from a 15-day window, and we're doing a maxima diagonal composite. So this is hour of the day, and this is a radiation value. The reason we're doing maxima is we try to get a clear sky condition over the 15-day window. So this is kind of give you a nice shape about the clear sky radiation coming. And we plot this all the observation radiation against the potential incoming. So this is calculated based on the size geolocation, but also the time zone. And this example shown here is a very good example without any time shift or any issue. So you can see everything aligned on time. They're symmetric, but also everything is far below the potential incoming radiation. And this is just an example. A couple of statistics generated here. So we're doing cross correlation between the time series here. Just make sure they're aligned. So the lag 0 means they are perfect aligned. And also there are no point exceeding the the potential incoming radiation here. And this check can be used to identify either timestamp shift, or maybe you have a mismatched time zone to your data, or maybe you have a daylight saving in your data system. Or sometimes you have a non-synchronized data stream coming from maybe 2 different logger or different acquisition system. And next will be an example about showing, okay, the similar check. Now we have showed this case. Their shift, the maximum correlation that happened at time lag 2. So it means you shift roughly 2 timestamp 1 hour. And also across the majority of the time window, you see there earlier sunrise. A lot of time you are exceeding the potential incoming radiation during the earlier morning. So this could be indicating the site have the shift of the timestamp. So either could be you have a mismatched time zone to your data stream. I think that might be the case. And if you have a consistent shift, usually it's either will be your mismatch of the end, or maybe starting of the timestamp, or maybe you have a time zone mismatch. In some case, you have an inconsistent shift across a window here. It might be a daylight saving issue, or maybe you resetting your clock at some certain point of the time, or maybe something other, or maybe other source of the issue. Okay. The second check we do is about physical range or plausible range check. It's pretty intuitive. So what we did is we, again, taking a year of the data, and this is incoming PPFD and the long wave radiation. We're plotting on the data against the, what is the possible physical range of this variable. Okay, so the orange line here indicating what is a possible range of this variable. And there are 2 ways we set up this range. So either it could be a physical range, possible range, if we know that, if we can define it. Or if we really hard to define it, we're using a distribution from all the current data set we have. So there's a Merflux across 400 sites we have. And we are using that to build what is the historical range from the network. What is the typical range of the long wave radiation, incoming radiation look like? And we are trying to identify any data point outside of this range. And because some of the variable, nature of some of the variable, for example, like a incoming radiation, you probably see slightly negative value a lot of time. So we are adding a buffer zone. This is 5% buffer zone to the upper and lower bound, just in case we don't flag a lot of data point. So the statistic here will be how many of the data point exceeding the possible range, and also plus minus 5% buffer zone here. The next check we are doing is about diurnal and seasonal check. This might be familiar to a lot of you. I'm thinking this is a different version of the physical range we just did. We just use it in a different way. Now with not just a time series, we're also plotting this time against the day, the hour of the day, but also by months. So again, this is a year of data by different window. Each window represents 1 month of data. So January all the way to December. And now we're plotting against the hour of the day. So this is will be, for example, this is a 1 month example. And each of the gray dot here is from the observation, a new submitted data, when we did derive the median of this new coming data. And this will be compared against the previous record from this side, from this variable. Okay, so for all the returning side, we build a database behind the thing about what is the historical range for each of the variable look like. And we are getting 2.5% all the way to 97.5% percentile. And we are comparing all the new submit data to the previous record. And we're using this check, try to find if there's any well, outlier or maybe unlikely value, or even you have a change shift of the sign convention like here. This is a soil heat flux. It's clearly indicating you have a flip of the sign convention in the latest year. Another type of issue can be used to identify here is about you have a shift of your full range in your variable. Like here, this is a CO2. And you can clearly see that the new CO2 data is higher than the previous record. Well, in this case, this might be real because we all know what's happening. But just give you an example about how you can use this check to identify the shift, even the subtle shift in your variable variability. The next check we are doing is about multivariate comparison, especially two variable. And we've done this for variable, they are physically relevant. So for example, like a show incoming to PPFD, or maybe a friction velocity to wind speed, or maybe a temperature, air temperature to sonic temperature. And also applied to variable, they are nearby. So for example, you have a temperature profile, or maybe you have other profile. We are adding that to this multivariate check. What we did here is, again, this is a 1 year time series of two variable. Now we're seeing what is the relationship look like. And supposedly this variable should have a kind of tight relationship based on the knowledge we have. And we're building, we are getting a regression and try to identify what is the point that actually deviate from this regression line here. So for example, all the red one is being identified as a potential outlier. They are showing up in the time series here. So if you see any short-term inconsistency, like a deviation here, usually it could be the sensor malfunction, or maybe if this is a radiation variable, maybe one of them being shaded, like a case here. So PPFD is lower than the show incoming in this case periodically. So this is indicating this during certain period of the time the sensor is being shaded. Or it could be one of the sensors get contaminated. For example, in the winter time, if you have a snow cover, one of your sensors, you can see one of the radiation sensor might be just 0 for a lot of time. It might be a case, or maybe the fallen level, southern little force, anything like that. And the statistic from this check will be the regression, slope, R squared, but also how many points actually deviate from this line. We're using the same check for long-term, the long-term trend, or maybe a step change in your data. So again, the similar example about PPFD and show incoming, but now we're looking at what is the year-to-year change in your slope here. So this is a change of the regression slope over the year, and the changes could be up to 25% over the year actually. And this indicate one of the sensor might be drifting. So either due to sensor degradation, or maybe you have a new sensor, or maybe you have a recalibration of your sensor over a certain type of the year. Next check would be, we are doing also the U-star filtering check. So one of the requirements for one flux processing is we ask the CO2 fluxes not be filtered by U-star threshold. So we are kind of checking this just to make sure we don't double filtering the CO2 fluxes. And this is one of the check we are planning to do in the future. And you might see, some of you might see the figure already showing up. So we're kind of experimenting it a little bit. So this is a variable availability. So the heat map here shows by year, each of the variable, what is the percentage of the data availability look like for each of the year. Sorry about the color code, but the red one means you have a higher availability. That's good. But the white one means, yeah, it's missing, or maybe just no data in this year. A couple of things we want to know about the data here is, okay, during which year, which variable don't have data. So this could be indicating about long gap might causing the issue about processing in the future. Or maybe at a certain period of time, actually you have the sensor, you have the data, you just forget to include that in your submission, like here in this case. And there are some cases about inconsistent variable naming or qualifier over the year. That would be an example like this. So the soil temperature was provided as an aggregate one in the previous record, but you have a separate one in the last couple of years. And this could be creating some difficulty for users to use this data. And this is the last two module. I'll talk about the check. This is there are some new check we are planning to do in the future, and most of them is based on the feedback from data user. First one is about sigma family, or maybe the standard deviation, especially about the wind statistic here. This is W, so vertical wind velocity, standard deviation. And it's been provided last couple of years. We're finally adding a check about to check this variable. So we are checking it against the relationship to the U-star. For example, like this one here. For the slope is deviate from the typical Kaimo model suggested, but also you can see a curvature of the data set here. So this is indicating you probably have a variance here instead of standard deviation in this case. And this should be what the data look like actually. Another check we're adding is about the site convention here, especially a few variable that's really hard to detect. That, for example, like this is the storage of the sensible heat here. And if you don't look closely, you might mess up the site convention here. The orange line means indicating that the prototype, I mean the supposed diurnal pattern should look like. And the black one is from your data, and we're checking if they have a similar diurnal pattern to make sure you have the right site convention. Okay, so we went through pretty much all the check we are doing right now. And as I mentioned earlier, a lot of these checks, they are run automatically, or at least by the machine. And what is the output here before we get the QQC report? So for each of the check, we generate a lot of logs. We're logging a lot of things, but this is more machine readable logs. So we're logging everything we found during the check. We also generate a lot of figures. For each of the check here, we generate a series of the figures here. They're hosted on a FTP, and each of that will be linked to a figure here. So once we have an output, M team will come into and start the review process. And that's why it took so long, as Daniel mentioned earlier. We're doing this in a batch, and we typically took 1 to 2 months per batch to finish the review process. And once we finish the review process, we kind of writing a QQC report or email and send it to you. Then this is your email look like. the component about the summary of the QQC, and there's some additional link to all the figure we just generated, and what is the original file get combined here to run a QQC. You got a link to. But most important part is this QQC issue. So it takes some human effort to review and summarize the thing and write it down, and also provide a link to all these figures here. So this is the last slide for the first part of the presentation. I want to come back to this pipeline here. So you're familiar with this pipeline right now. We started this process about 2017, and it worked pretty well and enabled us to keep up the growth of the network, to publish and to check the data as in the last couple of years. But we do see that's a really growing trend of the people reduced to a Merflux, for example, like this red one. The line here shows the cumulative number of the site reduced in Merflux since 2013. We have a better record about everything. And blue one means the site submitting data since then. And the purple one is the site published data. But also the gray bar here indicating the site actually submitting data every year. So we do see a growing trend of the people and sites submitting data in the last couple of years. And this is a number of the QQC review we have to finish actually in the last couple of years. So we are pretty good, keep track, but also we are hitting a roadblock in the especially the last 2 years. We're seeing more than 400 QQC review and need to be, and it takes some time. So this brings up why we're having this mini workshop today, but not just go over the QQC current state, but also try to point out what the future could be, and in order to support the community. So I'd like to take a pause here. I think we are done for the first part of the presentation. And before we jump into the future state, let's maybe talk about do people have any question about what the current state of the QQC? I'd like to, maybe let me stop sharing for now. Now we're open floor for any question regarding the current QQC pipeline or any of the check module or any of the thing we're doing right now. So feel free to put it in the chat, or maybe just raise your hand, unmute yourself. Or if you like to, you can also put in the Google Doc with just the share provided in the chat. So anyone?
I have a question.
Yes, go ahead. Gabriel, yep.
Yes, hello. So the QA/QC process is pretty much automated, and I've seen the results come out, and it's great. But before sending the data, are some of those tools that are used to perform those checks available in some sort of package?
Not currently. Yeah, okay. I heard about we heard about a lot of people asking that. So maybe the question would be, are you looking for a tool you can do, or are you looking for?
Yeah, well, I mean,
yeah,
there's a whole bunch of data that I look at on almost a daily basis that comes from different places, different loggers, and there's a plethora of problems that can arise, and finding those issues more easily before even submitting, as I'm putting the data together, would be useful. So I was just wondering whether some of those tools were individually available, or if we get the report directly and then we deal with it. So
okay,
kind of answers the question.
Okay. I don't know the answer, but we're thinking about a couple of possibilities for the future. Depends on what people are looking for, right? So I think there are a couple of ways. So one of the consideration we're building the future QQC is try to, well, let's talk about that in the next section anyway. It's about trying to enable this QQC process to happen more a little bit more real time. So you don't have to wait for another 2 months to get back the feedback. Maybe you can like a platform. I think there are some other examples. So like a platform, you can submit your data and maybe you get a feedback in a day, and you can address the issue immediately. And I think that's one way. Another way might be, I think I don't know if people are willing to do a little bit coding themselves, or some of this community share repository available, so people can just contribute a piece of the code. But you probably need to take some time to incorporate all this into your, well, it depends on which platform language you're using, right? So, and another way would be, I think a lot of the idea we're using for QQC is not that heavy actually. So if you know the idea, if you know what's behind the theory here, you should be able to build something into your QQC pipeline. So for example, like a multivariate check, right? Idea is pretty simple. You just plot two and try to find if the relationship is good or not. And I think it's pretty easy to replicate in any of the platform possible. So I think there are a couple paths where it depends on what people's interests. Thank you. Run the check, okay. I'm looking at the chat right now. Okay. I think pretty much about the same question Gabriel just had. Does anyone have any other question about the current QQC or anything else? So Nicholas just asking about, when you are doing the multivariate check, are you comparing every possible combination of variable? The answer is no, not now. We've been holding up because the reviewing process takes time. And we realize that if we're adding more combination, we're adding more time trying to review them. And we need a different way of reviewing this before we're adding more variable. But I think the idea is try to do this for more combination of the variable when possible. And this could be very helpful actually. Any other question or? Energy balance. Thanks, Sean. Yeah, we should. Yeah, we should do that in the future. Sure, for sure. Yeah, we are seeing. We haven't checked that in the past until recently. I think we need to add that to the process, especially for one flux processing. One of the steps is try to do the energy balance closure correction. And if you have very biased energy balance, it could cause some of the trouble in the further processing. But for other reasons too, I think we need to add that to the check. That's a good idea. Tomer?
Yeah, I wanted to know, can you hear me?
Yes.
Okay, I wanted to know how much of it is actually automated, because we're submitting the files, format QAQC is happening, right, automatically right now. And then the graphs are generated, and there's the results of this analysis. Do you actually have like an output that you already can get out of it that we can see if it's good or not before you even look at it? Or do you still do it manually, looking at the graphs and finding out?
Yeah, unfortunately, it might be a later case. So we're adding a couple things right now. So because we're seeing more size, so we're adding a couple things right now. A second, like additional information right now. So to help us to understand which of the figure to check or maybe take a look before we start a review process. And that's why we're having this workshop right now. Just we'll talk about in the next phase about what we have and what potentially can be used to facilitate, speed up the process. but it still takes some time for us to build a fully automatic process about the QAQC. And one of the reasons is it's more complicated than the format QAQC actually, and a lot of flag could be, a lot of warning error could be flagged during the process. If you show everything, it will be really hard to comprehend actually. So we'll try to condense them and make a better structure before we're showing that to people. But I think it's a good question before we move on to the next part of the presentation. What should a QAQC look like in the next stage? Let me share the screen again. Okay. So thanks for all the great question and feedback. Let's talk about the future. What the future should look like. I think for